Next speaker, you might already know him from yesterday, is Yoann again. And this time it will be about the Principia Softwarica.
Yes, thanks. I'm here to talk about the Principia Softwarica project that I started actually many years ago. And it's really three things which are represented by those three columns. So first, it's a series of books explaining the code of Plane 9. And so there's a book about the kernel, there's a book about the compiler, the linker, about the windowing system, about the graphic stacks. So there's 15 books actually. And the goal each time is to explain the whole code of a program. And so to explain the whole software stack. Then it's a new Plane 9 fork to support the production of those books. And finally, it's a new way to build Plane 9 using Docker. And so that you can, for students, he can play with Principia Softwarica and build it on Linux or Mac OS or Windows and test it with a QEMU or on a Raspberry Pi. So it's those three things. But the main goal is to teach students like the whole software stack. And so yeah, just before why. And so because I think the best engineers are the ones who understand the whole software stack. And so as a small anecdote, so I was a software engineer at Facebook around 2009. And there, if you had to work on the back end, each time you were linking even a small program, but that was pulling lots of libraries, you had to wait 10 seconds or 20 seconds or 30 seconds. I don't remember the time, but it felt an eternity. Like everybody that was working on the back end had to wait a long time just to link. I'm not even talking about the compiling part, but it was incredibly slow. And most of the engineers at Facebook are like, yes, that's life. That's how it is. There's nothing we can do. So we had to wait for Yoann Lansdale at Google to make a new linker, Gold, and that significantly improved the speed of linking. And so that speed up everybody. Every engineer actually in the Silicon Valley, not just at Google, were faster now. So Yoann Lansdale was not a young hotshot. He was not like a young rock star programmer at Facebook or Google who wanted to prove to all the other engineers that he was. No, he was an old, I hope I don't offend him, but he was an old Unix guru with a beard. And the reason is because every young engineer, none of them understood the whole software stack. None of them had the balls to had the courage to make a new linker. And so in my career, like every time, like the best engineers were the one who understood the full software stack. And so I saw there's a huge education gap among young engineers. And so as another thing, so Keith Adams, a colleague, one of his favorite questions in interview when he was interviewing candidates to join Facebook was like, okay, what happens when you type ls in a terminal window? So it's a very simple question, but actually it involves the shell, the C library, the kernel, the windowing system, the graphic stack. It involves lots of layers. And many candidates, after 1 minute, they were done. But if you know the full software stack, you could spend hours trying to answer these questions. And most engineers could not. And so nowadays, when you talk like, yeah, I'm a full stack engineer. I can work on Node.js on the back end, and I can work on React on the front end. I'm a full stack engineer. No, that's not a full stack engineer. You know very little. And so, and I will argue that the AI era makes this even more important. So as an engineer, we're gonna write less code. So you need even more understanding. You need even more to understand the context in which your program are deployed. And actually, it's funny because if you use tools like Cloud Code right now, it looks like a very good Unix programmer for the 80s. It's like using Hawk, it's using sed, it's using grep, it's using all these old Unix commands. And actually, one of the book of Principia is explaining all these programs. And so, yeah, it's very important to understand the whole software stack. The problem is that the stack is enormous. And so if you take the Linux kernel, it's 40 million lines of code. GCC is 15 millions. Xwindow is 500K. Xterm, just the terminal emulator, it's already 88K, 88,000 lines of code. And so, of course, the Linux kernel has lots of device drivers, and so you could reduce Linux kernel to the core, but the core will still be huge, will still be a huge number of lines of code. And so here is a tree map, like just to give a sense of scale of like every rectangle is proportional to the number of lines of code of the project. So the Linux kernel is huge. You have GCC there. You have binutils, which contain the linker, is 700K. And so this little green rectangle there, that's the whole of Plane 9. The whole thing, not just the kernel. Like you have the tool chain, you have the shell, you have the build system, you have the graphics library, you have the network stack. Everything fits into this little green rectangle. With 180,000 K, you have everything. And so why? And so why is Plane 9 is so small? And so as an example, so if you look at the windowing system of Plane 9, so Rio, is just 8,000 lines of code. 8,000 lines. So Xorg is million lines of code. Actually, Xterm, like I said just before, Xterm, which is just a very small component of X window, is already 88,000 lines of code, which is 10 times more than the whole windowing system in Plane 9. And why is that? Because and actually, Rio has an embedded terminal inside, and the code of the embedded terminal inside Rio is less than 1K. So 100 times less code than in X window if you compare. Tab completion. No, Xterm doesn't have any completion, and so. Xterm has electronic simulation. No, Bash provide tab completion, not Xterm. Xterm is actually not doing a lot, and so why is that? Because in Plane 9. If you have a program that want to write on the console, you just use /devcons. And whether this terminal is connected to a real physical terminal or is one window inside Rio, it's the same, because inside the Plane 9 kernel, there's a few abstraction like per process namespace, union mount, and user space file system that allows to have this concept of virtual devices. And instead in Linux, they had to invent this TILI-type device, and then you have this pseudo TILI-type device, this PTY device, and then you have a master on a slave of device, and you have this VT100. So you have lots of things, lots of concepts that don't combine very well. Instead, in Plane 9, you have a few concepts that combine very well. And so I would argue that Plane 9 is an ideal teaching OS, and OS in the broad sense, not just the kernel. So it's open source, it's small, it's real, it's complete. That is not just the kernel, it's also a windowing system, a graphics stack, a network stack. It's coherent, it's self-hosting, so it's lots of things. And so the idea of Principia Softwarica is to repurpose Plane 9 from an old research OS to a new teaching OS, and to have books explaining all the source code of all the essential programs for a programmer. And my hypothesis is that if you understand the whole software stack of one elegant OS, it gives you good intuition to understand the software stack of the other OS. That is, if you understand fully Plane 9, you will be a better Linux engineer, because you will. It's not exactly the same, but you will have seen concepts that will transpose to these different operating systems. You will be a better macOS engineer. You will be maybe not a better Windows engineer, but because the distance is too big. But still, that's the idea. And so yes, so Principia Softwarica is a series of books. And so I've decomposed them in different categories. So the first category is the core system. And so there's one book about the kernel. And I decided to focus on the kernel for the Raspberry Pi, so 9Pi, which is about 35,000 lines of code. If you take the portable part of the kernel and the Raspberry Pi specific, it's just 35,000 lines of code total. And I have this column LOE for lines of explanation, which is the explanation that I've added in the book. And so right now it's 700 pages, actually. The book is 700 pages. There's a book about the core libraries, a book about the shell, a book about the compiler, a book about the assembler, the linker. So again, here, I decided to explain the code of 5C, 5A, and 5L. So the ARM assembler, ARM linker, and ARM compiler, because ARM is a far simpler architecture than x86 to explain. So in a teaching context, there's no point in understanding the whole ugly corners of x86. And so it's important to understand the concept. And so that's why I focused on the ARM architecture. Then there's a book about the editor head, about the build system, the debugger, the profilers, There's a book about the graphic stack, about the windowing system, Rio, so that's what I mentioned, which is about 8,000 lines of code. And so I've added 4,000 lines of explanation in this book, the network stack, and then one book about that gather all the utilities, the small utilities, which are small programs, like Hawk, sed, grep, that actually are used by this Cloud Code a lot recently. And so actually, since the publication, I've added 2 other books. So there's one book about Motra, the web browser, and another book about the lib panel, which is like the toolkit to write GUI programs. And so, yeah, so in total, it's 15 books, and that covers about 180K lines of code. And so those books contain the whole code of Plan 9. So there's explanation, but it contains the whole code. Because I think if you want to fully understand the software stack, you need to understand the whole code. And so to give a sense of scale, and so if with 15 books you cover the 180,000 lines of code, so that's what you have. You have the entire Plan 9 operating system, the kernel, the shell, the graphics stack, with 15 books. If you wanted to explain Xterm, you will need 7 books. If you wanted to explain Bash, if you wanted to explain just Bash, just one program, one shell, it would be 15 books. Vim, it will be twice the amount of books of Plan 9. Xwindow, it's huge. glibc, it's 125. Binutils, which contain the linker, will be 58 books. If you wanted to expand the Linux, that would be big. So of course, again, like Linux contains lots of device drivers, so it's a bit cheating. But still, like the core of the Linux kernel will be big. And GCC, ls is in is not there. It's not in the find utils actually.
It's about 5,000 lines of code for new ls.
So yeah, like yeah, it's terrible.
If anyone's new.
Yeah.
I was looking at it earlier.
And so, and actually, the open source community realized this, and so GCC is too big, and Xwindow is too big, and so that's why they made Wayland, which will be only 100 books, and Clang, which will be only 68 books. But actually, it's not even right, because Clang is relying on LLVM, which will be 1,000 books. And so there's no hope, really, even if when they try to simplify. It has to be, like Plan 9 was designed from the start from a small team of insanely great programmers, and that's the only way you could have like a small system that covers all those things. And so then the question is, how do you explain the code of Plan 9? And so I'm using a technique called Literate programming, invented by Donald Knuth in 1984. And the idea is to have a book where you mix the code and the documentation together, and that you present the code in the order that you think the reader will be able to understand the code in a better way, not the order imposed by the compiler. And so you can show code piece by piece, you can separate concerns, so you can present the code in very, very flexible way. And so the tool I'm using is NoWeb. And so in this tool, there's a few important things to know. So you can define a chunk. So you use this less than, a chunk name, more than, equal, and then you can define the content of this chunk. And then inside this chunk, you can reference other chunk with this less than, chunk name, more than. So here is a little 101 programming course on literate programming. And so here on the left, so I have this toy kernel.nw, nw for NoWeb file. And so that will be a book explaining a toy kernel. But it's just like to give an idea of how literate programming works. And so in this file, you can use LaTeX command. So you have this anti// subsection process to define a section. And then you write some English, like the proc structure is the most important kernel structure. And then you use this less than proc.h, where the chunk name will be the name of a file, okay? And then inside this chunk, you can write C code. You can write any C code. And inside this chunk, you can reference, you can use other chunk names. So you say, oh, the proc field has 2 fields. It has a PID and a lock. And then there's other fields that I will define later. That will be defined later in the document. And so you do that. And then when you pass this through a pipeline of commands, you get a PDF output with a PDF LaTeX, where you have the process with a numbered subsection, the proc structure, and you have the code that is typeset in a different font, in a smaller font actually also. And you have this number 6a, which allows to reference chunk. So that means the proc other field, he has this number 6e, which means it's defined at page 6, and it's an e element inside this page. And so here, if I go back on the left, sorry, I have another subsection for main. And so the kernel entry point is main, which after summalization calls the most important function schedule. And again, you have a chunk that defines the kernel.c, where you see main, initialization. You don't show the code of initialization because it's not important. What's important is to understand that the most important function inside main is the call to schedule. That's called the scheduler. Okay. So thanks to literate programming, you don't overwhelm the reader. For example, if you want to look inside the plainline kernel for the proc structure, it has about 80 fields. 80 fields. So that's, if you look at the code, that's overwhelming. For someone who tried to understand the kernel, you have, wow, 80 fields. That's a lot to take. Instead, in the book, you can focus on the most important field first. You can say, okay, for now, what's very important to understand is that there's a PID field and a lock. And that's, I will explain later the field. Like for advanced, there's certain things that are used for advanced features that I will explain later. In the same way here for the main, it's very important for the reader to understand the main control flow of the program. And so the initialization you can define later. And yeah, the last thing about literate programming is that you can actually define a chunk in pieces. And so, for example, initialization is defined 2 times. It's defined the first time, oh, there's some global initialization with the call to ginit, and then there's some remaining initialization where you use the same chunk name. And actually, when you look at the LaTeX output, you have this plus equal to say, oh, this chunk of code is appended to the previous one. And again, here you define at the very end you define the last field, and you can add explanation of this about these advanced proc fields. And so how it works then in practice is that you have this toy-kernel.nw file with the code and the documentation mixed together, put in a certain order that the author thinks is the best to understand the code. And then you use this nowif command to take the noweb file and you generate a .tex file. And then you use PDF LaTeX to process this LaTeX file and generate a toy-kernel.pdf file. Okay, that's one part that from this you generate the book. And the other thing is that you can use the notangle command -rproc.h and then that with the command to generate the code. And so you can put this into a MK file to automate this part. But the important part is that at the end, you have like a proc.h file and a kernel.c file. You can use your compiler on it. You can use your regular compiler. And so why books? Why books? So are books still the best medium in 2026 to teach programs, to teach code? And I would argue, yeah, books have been here for thousands of years. They survive TV, they survive internet, they survive even MOOC, like this massive online computer course. So I think they're great. And I still read books. It's one of the best ways to learn something and to teach something. And so another alternatives to understand a big program is to use an IDE. But the problem, like I mentioned before, there's no narrative. There's no, like if you look at the code of proc.h, you would have 80 fields. And so that's great. You can navigate in the code base from the use to definition and so on, but it's overwhelming for the reader. And so you can use AI. And so AI will be, again, useful to, oh, I have some code that I don't understand, but you will just get a local explanation of this. You will not get a full picture of the whole program. And you don't have a coherent narrative to explain the code. And so actually, I'm not using NoWeb. I'm using a tool that I developed called SyncWeb that actually brings some of the features of IDE inside the book. But I don't have much time to explain. But so this is actually the book about the linker. And so you see that at the top you have the code of the linker, where you have this call to ASMB to generate the code, and then you have this call to undef to check for definition use of undefined function of undefined entities, and then under the undef, you have these uses, and you have a list of entities that are automatically produced by ThinkWeb. And so it automatically gives you all the entities that are used by this block of code. And so it says, oh, there's a use of ASMB that is defined page 41. There's a use of the global first P, last P. So actually, you don't see them in this code because it's in the previous pages, but the index is for the whole code. Then there's a call to undef, and actually, if you use a PDF viewer like Evince on Linux, you can hover the page reference, and you will get a peek preview of the chunk definition. And so it's a bit like an IDE when you're inside. There's a function call, and you can put your cursor. You can hover on the entity, and you will get the definition of the function that you're calling. And and so here, for example, actually, here is the code of the linker that I mentioned before. Like a linker is not very complicated. If you look at the undef function, what it does is that it iterates over the hash, the symbol table for all the symbol in the program. And if the symbol type field is still sxref, that means it's not stext, it's not sdata, it's not sbss. That is, it does not be assigned a section in the binary. Then you have this warning say, hey, something is not defined. So a linker is not very complicated. And so yeah, like I said before, I think what you learn with Plane 9, you can apply everywhere. And so understanding one small, elegant OS gives you deep intuition about Linux, macOS, and not Windows maybe. And so, and the good thing is that actually the books are explaining programs that you don't even have to use Plane 9 to use this program. You can with Plane 9 port, you can actually use the RC shell, you can use Awk, you can use sed, so you can use the programs that are explained. And with Gokuen 9 CC that I presented yesterday, you can also use the Plane 9 toolchain, and so you can understand the whole toolchain and use it on Linux, on Windows, or macOS. And so that's a series of books. And so to produce those books, I had to fork, to yet another fork of Plane 9. And so I will go quickly, but to make those books, I had to take the code, put them into this noweb file, and then as I was doing that, I rewrite quite a bit the code. I removed some dead code. Some globals were not super clear, the name, so I just renamed because it was just shorter to rename than to write text to explain why it was a bad name. I've added subfolders, so the kernel now there's a process subfolder, a concurrency subfolder. So I reorganized quite a bit the code so that, because it's a teaching context, the goal is really to teach the code, so I had to fork. And so the code is available on GitHub in this repository. And so here I just show the top level structure of this new repository. So at the top you have this assemblers directory where you have the code of 5A and 8A. So in Principia, I just focus on the ARM architecture and the x86 architecture because it's a teaching context. I don't want to support like the Spark or whatever. And this is in each directory there's this .nw file for the Literate program. So there's the assemblers directory has the assembler.nw. There's a book about the builder, about the compiler, the debugger, the kernel. You have all these subfolder and this kernel.nw file that explain the kernel. And then on the right, you have this MK file target PC and target PI, because it can the whole thing can be built for either for the PC for x86, and that you can use QEMU to boot the Plane 9, or you can also make it on SD card and boot with a Raspberry Pi. And so, yeah, I would argue that it's easier for students to discover where the assembler is if it's in assembler/5A rather than in sys-src command 5A. And so, like, I reorganize the code, I forked because then it's easier for the students. Yeah, actually, a good strategy to find bugs in Plane 9 is actually to try to explain the code. So I find a few bugs in the kernel and in a few programs because I was trying to explain the code and I could not because actually the code was buggy. And so it's a good way to find bugs also. It's quite expensive, takes time. And so, yeah, so another thing about ThinkWeb that I don't have much time to describe is that traditional literate programming tool. So you use them to generate the code, but then you cannot modify the code. So if to modify the code, you have to modify the original document, the literate program, and then you regenerate the code, which can be quite annoying. So instead, with my tool, with ThinkWeb, you can actually modify the code, and it propagates the modification to the original document. So it's easier to develop. And so I don't have much time, but it's also, the code of ThinkWeb is also on GitHub. And it also does the code indexing to automatically index and write index reference into the PDF. And so that's a new Plain 9 fork. And finally, it's a new way to build Plain 9 using Docker. And so the problem that it tries that are to solve, so the big problem is that in a teaching context, you have students, and you want them to modify the code and to rebuild and to boot from Linux, Mac OS, Windows. You want them to use their own editor. You want to remove friction for students. You want to remove friction and still make them able to play with Plain 9. And so the first problem is that Plain 9 use a special C dialect with some special extension, and so you cannot use GCC or Clang to compile Plain 9. And also, the Plain 9 operating system is using some custom assembler, so there's a lot of assembly files that you cannot compile. And the second problem is that the good thing is that you can use 9 front or 9 legacy CD image, and you can boot this CD image with QEMU, and so the student can play with Plain 9 easily, thanks to QEMU. But what if now you want to modify the code of 9 front? So how, from your 9 front modification, you rebuild a new CD image so that you can test and so on? And so it was not really designed for that. So fortunately, like I mentioned yesterday, there's been prior art, so there's work in Inferno, there's work on Plain 9 port, there was work on KenCC, and I have my own program called Goken 9cc that packs all the Plain 9 toolchain in one program, in one repo that you can build with GCC and Clang, and then you can use that to cross-compile Principia Softwarica. And so I will not spend too much time because I already explained that yesterday, but that's a Docker file for Goken, where you install GCC, you run configure, and then at the end, you're in a container where you have the Plain 9 toolchain. And once you have this, now this is a Docker file for Principia Softwarica itself. So you have this from Padioleau Goken. So that's now I'm in a container with Goken. So I'm in a good place. And I can copy the mkconfig.pc to mkconfig. And then I run mk and mk install. I run mk kernel. And I've built I've been Principia Softwarica for 386. Now I do the same thing for ARM. I copy a different config file. Once I've done that, I install the DOS-FS tools because Principia Softwarica is using the vfat file system to store the Plain 9 distribution because it's like a file system that is supported by every OS. So it's easy then for the students to inspect the artifact produced. And so you use DD to create an image file. You make the vfat file system on it. Then you copy what you've built before onto this image. You had the boot sector, and now you have a DOSDisk.image file that contains the Plain 9 distribution that you can boot. And so here actually that's the only commands you need to build all of Plain 9 and Goker. And so actually I have a small demo. So here I'm inside the Principia directory. I'm on macOS, and I can do mkrun. And that will use the DOSDisk.image file that I just built to run QEMU. And now you can use ls, and you can use arraytrace-c ls, so that you can understand how ls work, which was what I was talking at the beginning of the talk. And so rat trace is like strace on Linux. And so here you can see all the different system calls. You can see pred, you can see the brk, which is syscall number 5. You can see the open system call, which is number 6. You can see the exit system call, which is number 3. And that the cool thing is that you can quit. You can use your favorite editor, which is Emacs. You go to the libcore directory, libc, you go to 9syscall, you modify the, and that's the file that contains all the syscall number. Actually, you can see these special comments. That's the special comments that are left by SyncWeb, so that when I modify the code, that's what allows me to modify back the literate document. And so here I can modify open to be 42. So actually, there's 39 syscall only in and so I save. And now I'm cleaning everything. So I'm using MK that was built from Gokun previously. And then I type make, and that will build all the core libraries, all the C library, all the programs. We'll be using ape also in PCC. It will use IRR. So it builds the all 180,000 lines of code. And it just takes a few seconds. And then you can install this program in a special directory that will allow them to build a distribution. So it copies FTPD, it copies chmod, it copies mount, it copies lots of things. Then I make the kernel. Then I make the disk image. So I remake this DOS-disk.image file. And now I can run. I can rerun. And I can even run Rio because. And now there's a Rio that was recompiled with different system call, but it works. And if it's hard. Now if I run arraytrace-cls, see open 42. So this was an incredible feeling for me. Like the idea that you can just modify one file, recompile, it takes a few seconds, and you got the whole distribution working. Like imagine if you want to do that with Linux. The time it will take, like I don't even know which file to modify. There's probably a few files. It's not just one file like here. You will probably need to modify one file in the kernel, one file in glibc. Like you will need to recompile all Xwindow. How do I get all the Xwindow program? It's an incredible feeling that you can have. Like in a few seconds, I was able to recompile everything. And I can even run a browser. It's a good website. So the network is working. And so this operating system, this teaching OS, has the network stack. It has the whole network stack. It has a web browser. You can even have image here. Come on. That's images. And so you have the whole operating system is just 180,000 lines of code explained by just 15 books. Xterm will be 7 books, just as a reminder. And so, yeah. And so, related work, I don't know how much time I have. See, I'm still good. And so, there's some related work. And so actually, I've heard about Oberon in this room like in the last, yesterday. So the closest to this Principia Softwarica project is the project Oberon. So Oberon was a language and operating system and windowing system that was designed by Niklaus Wirth, so the guy who invented Pascal. So yeah. And it is a small book. It's about 400 pages, if I remember correctly. And you have the whole code of the whole Oberon operating system, the whole Oberon compiler, and also a windowing system. Actually, the windowing system, there's a lot of ideas in Acme that comes from Oberon. And so it's a great book, but the problem is that if you want to write a program for the Oberon operating system, you have to use Oberon. So it's not a universal operating system. It's a bit like Smalltalk. It's a nice world, but you have to write in Smalltalk. And so instead, Plain 9 and Unix are universal. They can run any program. You have this other fantastic book called The Elements of Computing System, where in this book they start from the NAND gate and they build a full processor. And then from that they build a toy assembler, a toy compiler, and a toy operating system. So it's a fantastic book. The problem is that it's not a real language, it's not a real OS, it's not a real... So for understanding architecture, I think it's great, but for understanding like a real operating system, a real compiler, it's not the best. And the other book is this Computer System, A Programmer's Perspective, also an incredible book that gives you a full picture of the whole software stack. So actually, it's one of the few books that explain how a linker works, how malloc works, how a debugger works. But each time it's just a theory. It's not you do not see the full code of a linker. You don't see the full code of a debugger. Instead, with Principia Softwarica, you have just 15 books. It's a lot, but it's like the whole thing. You understand fully to the smallest detail. And so future work, so the main work is to add explanation. And so the goal would be to have a ratio of line of explanation to lines of code close to 1. And so we're still far from that. Another goal would be to be self-hosting. Actually, right now, you cannot build Principia Softwarica from Principia Softwarica. Right now, you have to cross-compile it. So it will not be, it's not that hard, but it's still some work. And another future work would be to merge Gherkin and Principia codebase. They started from different offspring of Plan 9, but it would be good to merge them back. And so as a conclusion, so I hope that Principia Softwarica removes the mental barrier people have that prevent them to extend the tool they use. They see a linker and they see a black box. They say, yeah, it's impossible to modify this thing. It must be very, very hard. No, a linker is not very complicated. The graphic stack is not that complicated. A network stack is not that very complicated. And so if you fully understand one elegant OS, I think it gives you intuition for all the other OS. And another goal of Principia Softwarica is that, like actually Brian Stewart mentioned before, that in other fields, like the students, they study from the masters. In architecture, in the real architecture, they will study the work of Le Corbusier, of Frank Lloyd Wright. They will look at their actual work. And so you can actually read the code of the masters of our field, which are Ken Thompson, Rob Pike, Tom Duff. The code they wrote was like 40 years ago, but it's some part aged, but it's still incredible code. And so you can learn a lot by reading their code. And if you do that, you will understand the whole software stack. You will become a better engineer. And if someone asks you what happens when you type ls, you can actually fully understand this question for hours. And so clone it, build it, and read the books. And thank you.
Great, thank you very much. And it looks like we have some questions.
Yeah, I have 2 questions. One is, what's the motivation for getting the lines of explanation closer to one-to-one with lines of code? Like that seems to be like against the principles of, things like you don't need to comment for I equals 0, like I plus.
Yeah, I agree with you. And I also don't like to. But so in my experience, so I finished a few books, and I'm also like, I totally agree with you. But in practice, I found out that if you really want to understand like the code base, it requires quite a lot of explanation. And so, but when I mean explanation, it's also diagrams. It counts when I say the ratio lines of 1. It's also the section names. I count this as explanation actually, the structure. So in the end, you need a good amount of explanation. And the explanation I tried to not add like obvious things, but there's lots of things that are not that obvious actually. And you need a lot of explanation to, like if you look at the code of the linker, it's not that small, but there's a lot of tricky things to understand. And it's just one line of code, sometimes it's tricky.
One key is to not comment line by line. There's a whole bunch of context surrounding this often.
Yes. And so like you see this one line and you need the explanation. Actually, it's actually used there and you need this cooperation to work. And there's no comment in the code so much. And so yeah, you need a good amount of explanation.
Cool. And then the second one is, I guess, like in the learning self-hosting aspect of like how much of the 15 books have you consumed and found useful? In like writing it is, I guess, perhaps different than reading it. Like
yes. So my motivation for this was not to help other people. My main motivation was to learn. And so as I selfishly wrote these books to learn a full operating system, and I've learned a lot doing that. But I think like I spent lots of time actually, and my way to learn actually was to write the literate programming books, because it's a very good way to learn, that you have to structure you have to reorganize the code in sections, in chapters, etc. And so as I've done that, I think that I'm making possible for others to accelerate their learning. They can learn more quickly than me. But I constantly reread the book to refine, and many books are not finished. A few, maybe there's, on the 15 books, there's maybe 5 or 6 that are at good points, but there's still lots of work for, like the graphic stack, I don't understand that much. I didn't write the explanation yet. The network stack, I didn't write the explanation yet. The linkers, the assembler, the windowing system, I know very, very well now.
Thank you.
So on the teaching aspect of it, I guess that's when you said it's for your own edification, that kind of makes sense. But I'm wondering for teaching, if you looked at XV6 and how the book is.
Yeah, sure. So XV6 is great, but it doesn't have a network stack. It doesn't have a graphic stack. It's just the kernel. It's not, there's no toolchain actually. XV6, you need like the GCC toolchain. So for one part, and that's why, like, I had lots of candidates. When I started Principia Softwarica, I had lots of candidates. What is the ideal? Because I wanted to explain the whole software stack. What can I use? And so there was Minix, there was Unix v6, that's the Lion's book, the XV6, XENU is fantastic because XENU has a network stack. But Minix, for example, it doesn't have X window. It doesn't have a windowing system. So you need to explain X window now. And so XV6 is just for the kernel. And so I didn't want to write one book for the kernel and then another book that was completely disconnected for the windowing system. I wanted one coherent system. And that the beauty of Plan 9 is that you have one system where everything works together. And so you don't need a book on a kernel for a different, no, you have like the whole thing.
So the other question was, so on the chatter on 9fans, I saw that there were references to, and I kind of stopped reading after a while when it was going off the rails, but that the LLMs were used for summarization or generating any components.
So when I made this presentation and the paper, I still didn't use any LLM. I didn't use cloud code at all. And so all the numbers are in the tables are before any use of LLM. Since then, I've started to use Cloud Code, which is an amazing tool. And so I started to use Cloud Code to help for the English. I'm not an English native speaker, and I've experimented for the browser book for Motra. I experimented also to use it to try to do more work, and it's pretty good. It's not perfect, and that's why there's lots of interaction with it to refine the explanation. But yeah, I'm alone right now on this project. I've been working on this since 2014 almost. And so like the LLM is a great way for me to accelerate my outputs. Yes, yeah, you can, it's pretty good at this.
It wasn't quite clear. I was under the wrong assumption that it was pointed at, let's say, the Plan 9 code and, like summarized form.
No. It's actually a huge amount of work in this that I spent for 6 years, like almost full time, was decomposing the programs in chunks, in different chapters, in different sections. Or this procs field, this proc structure, like I need to decompose it in different parts. Like now this part is just for the profiling part. This part is just for the debugger part. This part, so I have all this aspect and separation of concepts. A huge amount of time was actually not writing the English, was like decomposing the program in a way that I think the order is the best for the reader to understand. And so then adding the English is still a lot, because like you also need to understand the whole code base. Right. Actually, a good thing also, because the code base is small, like LLM are great. Like they can take all of that in context, but I know LLM are a bit controversial here, so I will not talk about it.
It's tangential, but I think as far as translation, which is where like transformers were invented for,
Yes, they were made for that, and so it's hard to
They
not.
do a great job,
It's
actually,
not.
you know.
It's hard to not use them. It's
Yeah.
not. They were designed for this kind of thing in the end, and so
And you know, the lost in translation element of it is just there just as well as it could be with a human. You know, I think the bigger concern is like if you know you let it loose on the source code and say summarize it without really understanding what's
No,
and then having to verify what it's trying to
the way I
give
use
back.
it is like you have a professor that has PhD students, and the professor tells them, "Hey, get me a first draft of it," and then you come and you refine, and so that's how I use it, and it's been useful. But yeah, Brandon.
No, this is really cool. I mean, in terms of trying to reconceive of Plan 9, not as something as we hack on as nerds here or something, but as something as has wider appeal, right?
Yes.
That is quite interesting. And I would love to hear what your experience is from like reading the code, not having you gain a micro understanding of how the individual pieces work. But is there anything that you learned after going through the linker, after going through the kernel, after going through some of these things, and then getting a larger message about what Plan 9 is and how it's built and some of the philosophies behind it? What is something you can't get from just reading one of the pieces?
No, I mean, for example, just like the example I showed before, like with a windowing system,
Yeah.
like in some sense, like it looks like after making the, I feel like they've designed the whole Plan 9 so that Rob Pike could write a windowing system is just 8,000 lines of code. That is like the windowing system is the best book in the series because it's like incredible. It's just like 8,000 lines of code for a windowing system. It's insanely small. And the way they've done that is like all the concept of Plan 9, like the per process namespace, the virtual devices, the union mount, is like the 9P. Like you can run Rio under Rio, for example. If you want to do that with X window, they had to write a XNest special program to do that. Or like if you want to use Rio on the network, like they didn't have to do anything. Like X window was conceived to be a networked windowing system. Rio, they didn't have to do. So it feels like the whole thing was designed so that for Rio will be just 8,000 lines of code. Otherwise, yeah, it's like it's beautiful. Like you see even more the beauty of Plan 9. That is, you see all these few features that combine extremely well. And so, but for the linker, I don't have. For the toolchain, I don't have anything like that can interact well with the windowing system. It's hard to. I would have to think about what other thing I could see that maybe other people don't see after having written all those books.
Is that kind of your takeaway, that you think that before as they started to, before Plan 9 was written and they set out to write it, that they had in their minds a windowing system?
No, for sure. Like Rob Pike, actually, like one of the first windowing system, like before X window, before Apple, before there were actually Rob Pike wrote the Blitz. Huh?
I think he wrote 4 or 5 windowing systems.
Yeah, he wrote MPX, which was the first windowing system, and then he made a language like Newsquick, I think.
MTX was like the mux for the
Yes, and so and also that's the core of Plan 9. Plan 9 was invented because when they had Unix, there was no network and there was no graphics, and so when they started Plan 9, they said, okay, we have now network, we have now graphics, we have windowing system. Let's
Central to the entire project,
yes,
right?
I think so. I think like the windowing system was like a central thing. And then they needed a compiler, and Ken Thompson was there, and said, yeah, just write me a compiler.
Plan 9 was basically an answer to, well, we didn't have networking when Unix was invented, and we didn't have mice when Unix was invented. What
Yes.
can we do with these things?
Well, and to be fair, so you know, like while IP networking was taking hold, there was also a thing called circuit switching, and DataKit was a big component of it. And DataKit actually, for anyone that ever worked with it, it was very well integrated into the namespaces in Unix. So if you like work with DataKit now, it would feel very much like how
Interesting.
9 works with networks, you know, in terms of you just traverse some namespace and you are where you're gonna go, whatever.
But
Okay.
you will also see this, like if you read the build system book on MK, like you can see MK was redesigned because they had like inside, the make was good, but there was lots of ugly corner. And so they just rethink the thing, okay. And they just, there's just, I think MK is just 3,000 lines of code. And it's more powerful than Make in many, many aspects. And so the shell is the same thing. RC, like, okay, let's make it simpler. Like, we can redesign from scratch and make something simpler. And so each of those books, each time, let's redesign, let's make it simple. And that's the only way you can have, like, from the start, something as small as Plan 9.
I'm also curious, you shared this on the lists, of course, but have you workshopped this with anybody else? Have you had any other feedback from someone else who is...
Yes, actually, I had feedback from Donald Knut himself, who loved the project, and so that was like a huge boost.
Ego boost, yes, definitely.
I've shared that also with some of the creators of... I should not... No, I will not talk
What about someone who isn't already, you know, a master? Someone, I mean, have you, with like students or anything?
So I've worked on this, like, not secretly, but almost secretly for like a long time, and it's just like recently I started to make this presentation here, like announce it on the 9 fans, because before that I was like, I had this big project. It's a big project, like takes a lot of time to write those books too, and so I didn't know if I could finish it. And now I'm at a point where okay, there's a good shape. Some of the books, there's like 5 or 6 books that are quite good state, not fully finished, but almost. The rest is well structured, and so I have like, okay, I can finish this project. And now so. That's why I didn't. You're the first one that I share in some sense this project.
So you started this for yourself, and now you're seeing it as it's at a point where you can actually start potentially offer it to others.
Yes.
And you're on the beginning of that journey. Okay.
Yes. Even like Gherkin was an important part. Like to be able to, I wanted from the start like I want to be able to compile this from Linux or Mac OS, and so you need also the Gherkin project. And so I did some work on. I had before Gherkin I had another thing called Fork NCC, but it was brittle. It was working for me. But it wasn't. I knew that if I wanted to give it to a friend, there's gonna be. So you need lots of polishing, and so now it reached the point where it's quite polished, and so I will not need to spend too much time helping people if they want to install it.
Thank you very much.
Thanks.
All right, looks like that's it. Thank you again very much.